Welcome everybody. I'm Stefano Maffulli, and we're here to talk a little bit about Zenko. And finally, we have reached the number 1.0 release, which in software development is always a big milestone, and in open source software is even a bigger deal. And we're particularly happy about this achievement. So Zenko is a data controller that allows you to replicate, move, and search data across private and public clouds. And during the next 30, 40 minutes, we're going to be talking a little bit about its features, how it came about, and what problems it solves. So next slide. I'm here with two colleagues, more than colleagues. And so why don't you introduce yourself?
Sure. So I'm Nimide Harman. I'm the Zenko product manager.
Hello, I'm Giorgio Wegni. I'm the CTO of Security.
Wonderful. So in the next minute, Nimide will give you a live demo of how Zenko works and what kind of problem it solves based on a scenario. Then Giorgio will give an overview of Zenko, how it came about, and the technical details. And then I'm going to give you an overview of what's coming next and how you can join the open source community that is behind Zenko. And we'll give you plenty of time to ask questions. You can actually ask questions on the using GoToWebinar as we go, and we will review them at the end and answer. So there is a button on your screen that has questions written on, and that's where you enter them. Okay, let's get started. So multi-cloud is real. It's a big deal. We hear this mentioned many times, and even AWS CEO has mentioned that companies need to have to deal with multiple cloud for whatever they're doing. Analysts also confirm this. And even though a lot of the terminology and a lot of the research focuses on workloads and virtual machines, and why we talk about multi-cloud storage, it's in the same problem space. You have to deal with multiple vendors when it gets to your cloud strategy. And so we built Zenko to address specific problems. So one of the simpler ones is to have use Zenko as a way to replicate data in the cloud, in a secondary storage location, while your primary could be a data center, your own data center on premises, or one of the clouds. But you can use Zenko to replicate data from one application to another one very easily. Or another one that we are seeing already being tested by open source early adopters is Zenko as an edge collector of information from appliances or devices in a tiny instance, and use the replication engine of Zenko to replicate the data from the edge into a larger data center or public cloud for that, using use cases that enables that artificial intelligence, machine learning kind of application. Or other use case that we're seeing is multi-site content distribution, where Zenko can be used to replicate data between different storage locations based on, for example, compliance, like GDPR or data sovereignty issues that have been arising quite often. And one of the most important ones at this moment for us is the multi-cloud cloud media workflows, where we've seen Zenko being used by media broadcasters in studios to they want to use all the features that are peculiar or specific to some of the cloud providers, like Azure seems to have quite an edge on analytics and the smart tagging of recognizing videos that have specific features like dominant night scenarios, for example, or Google Cloud can be quite fast and has other specificities. Zenko is used to replicate data based on tags and objectives and smart decisions. Can be used to make smart decisions about data allocation in different clouds. And in fact, we have a large customer that is already adopting this kind of scenario, and with a mandate from the CEO to avoid vendor lock-in and use multiple clouds to achieve independence from and gain also the possibility to negotiate better prices and better deals. So with that said, as a summary, the benefits that we designed Zenko in mind, that we had in mind for the Zenko, is to give users choice and avoid lock-in, give them a chance to reduce cost in the cloud, and simplify also the management of multi-cloud scenarios. And now it's time for a demo. So while Nimede sets this up, we're going to see something starting from, there we go.
Okay, so the way I like to do demos is kind of use a use case and kind of walk you through features that we have using a fictional use case. So today's use case is going to be collaboration and research. So in this demo, I'm a researcher. So I am researching with labs all across the world: Germany, Paris, New York, San Francisco, and I have a few simple tasks I need to do. So I need to first click on my lab, and I already have some samples in here, but I actually need to make sure I replicate a few additional samples. So all the labs actually utilize the same clouds, and we need to make sure that each lab has access to data samples from any lab, no matter where they are in the world. So I need to write my newest samples to the cloud that we all share. So I need to upload these 3 samples here. So we can see that data file 1, 2, and 3 are now inside of this bucket for my lab. So this has actually been replicated to multiple locations, specifically to AWS and to GCP. So if we go ahead and go over to AWS and GCP, we can actually see that these files have been replicated. So let's see. Let's go ahead and go to GCP. So if we go to GCP, we see that my bucket, so this is the Uversky lab, and my files 1, 2, and 3, have been replicated. So if we go to AWS, we can see if replication has gone through there. Let's see. So if we go to AWS, it looks like the files have not yet been replicated. So we're going to go back to Orbit here, and we're going to go to our location status here. So we're going to basically check the status of a replication. We'll come back here occasionally just to make sure that this is replicating. So one thing that you can see here is that GCP seems to have replications going quite well, but we're having a few issues with AWS. So we'll keep checking back in here throughout the demo. So as a researcher, if we go back to our bucket here, we actually want to make sure that we have meaningful data appended to our data. So what we're going to do is actually add a few meaningful tags onto this data. So this is actually bacteria, a bacterial sample, and it's DNA. And this one, also bacteria. This is protein. And our last sample we uploaded is bacteria as well. And this is RNA sample. So we can actually do, once these tags have been completed, is we can go over here and we can kind of search all of the samples that have been uploaded by lab. So what I want to do is actually want to go to my lab, and I want to make sure that our we actually did get these samples uploaded, and I want to see how many samples we have of DNA. So what I'm going to do is search this, and I can actually see all of the DNA samples from my lab here. We can see the file that I just uploaded here is also showing up, data file 3. So if we go back to our location status, we can check out exactly what's going here. So we see that we have a few objects to AWS that have failed. So if we actually just click this, we see that the objects have failed from both the Germany lab and our lab. So what we can actually do is just go ahead and retry all of these. Give it a second to actually complete here. And we can basically retry all of those failures at once. So once we close this, we can go ahead and refresh this. Awesome. So what we're actually doing here is we're following the replication of all of those failed objects to see if they actually are replicated. Another way you can actually do this, aside from using your location status page, is you can go to the dashboard. So the dashboard gives you some useful information on how your replication is going and just some key things. So what we see here is we have 143 objects have been completed, and we still have 36 in our backlog. If we scroll down here, we can see a bit more information. So we see that we have 51.3 kilobytes of data managed between all of the clouds we're using, and this is between all the labs. And we also see that of that data, we can see how many objects are managed in AWS, GCP, and on Zenko itself. We can also get more useful metrics on capacity, objects, and memory. And we can break this down by time of day as well. So if we know that we're prone to have a lot of objects replicated at a specific time of day, this will give us more insight as to, whether or not the Germany lab is replicating a lot of objects at, let's say, 1 a.m. our time. So this actually helps you kind of see if you have any spikes in objects being loaded and kind of gives you more insight if you have any issues with replication. Okay, so with that concludes my demo of our UI.
I have a quick question for you. How did you set up the Zenko instance?
Sure. So the easiest way to set up the Zenko instance is to use our sandbox. We do have a deployment for 5-server and 3-server with Metal K8. But if you just want to try out the Zenko platform and just test it out and replicate a few things, the fastest way to do that is definitely using our Zenko sandbox. If you have a few minutes, I can actually just take you right. Oops. Okay, cool. So you can actually access that on our site itself.
Cool, thank you.
Yep.
Thank you for that demo. Giorgio, do you want to take it?
Perfect. Thank you. You can go to the next slide.
Let's just quickly switch present.
Yeah. Okay, perfect. Thank you. So I'm going to talk a bit about the architecture and technology behind Zenko, give a high-level overview. So if you go to the next slide. So Zenko itself is actually using piece of an open source project that we did earlier called Cloud Server. One of the advantages of Cloud Server was to pretty early on use containers. And containers allows us to scale from a very small deployment on a small VM or on a laptop, all the way to scale out clusters with hundreds of servers. For Zenko, Zenko does a lot of management of metadata, making copies across clouds. Clouds actually have issues where sometimes they're not available, and there's a lot of management to be done. It's actually a stack that is composed of more elements than just the cloud server stack. So we decided to go with Kubernetes as a way to orchestrate this platform. And so as you can see in this slide, so we have the S3 compatible API where all the clients actually talk directly to the S3 protocol. In the demo that Nimadi just did, we're using a UI, but everything is native S3 command. So there was a question about, do we have on metadata? Everything we do is actually native object metadata. and Zenko keeps track of it so that you don't have to go to the cloud each time. But if you were to disconnect Zenko, all your data is in the cloud with all the metadata that you need. There's a concept of a cache. I will talk more about it later on, but you can configure Zenko to cache some of your data for faster access and also for bandwidth reasons as well. There's a workflow engine, and we'll talk more about that later on, but it's basically applying all these policies to your data, how many copies to which cloud, managing the queues. We use Kafka for the actual dispatch of tasks into the system. And there's a lot of metadata going on, and we decided to use MongoDB as our metadata engine, and it does scale from a few nodes or one node to hundreds of servers if you need to. All of this can be configured directly in the system. We also have Orbit, which is a management portal that is free to use for anybody who wants to use it. If you synchronize Zenko to Orbit, you configure it into your Orbit, then you can do everything that Nimadi just did using a UI. You can also browse your data. You can also configure CRR. So the idea is that Orbit is completely free until 1 terabyte. And then after that, we need to discuss with Scality about a license. So far, it's free for everybody because we just started and we want to get as much feedback as possible. If you go to the next slide. So the idea is to give you a unified interface across any cloud, right? And one of the reasons why we open source is we think that there's a lot of different clouds that can be attached to Zenko, and we design it in a way that's very open. So we expect other people to help us and add more of these backends. So I'm happy to say that in version 1, we support Amazon, Google, Microsoft Azure, DigitalOcean, Wasabi, and Ceph as a backend store. Obviously, Scality Ring as well, which means, oh, it is in the slide. Nice. All of these clouds use different APIs, and thanks to Zenko, you can converge on the S3 API and use any S3 compatible application talking to Zenko that's fronting all your other clouds. If you move to the next slide. So Kubernetes, there's multiple ways to deploy Zenko, and one of them is to deploy on-prem using your own servers. And for that, you could use any Kubernetes version. Scality has our own version of a distribution of Kubernetes called Metal Kubernetes that will fully support and give SLA and maintain as an enterprise product. It's open source. You can look it up on GitHub. It comes with a lot of pre-configured and pre-installed enterprise features like the logging and the statistics and the access control that are directly configured there. Also, you could deploy Zenko in the cloud using Kubernetes host cloud infrastructure. So EKS on Amazon, AKS on Azure, and GKE on Google. Can also be deployed on VM as well if you prefer. But we are very happy about the choice of Kubernetes because it opens a lot of platforms, a lot of infrastructure for us, and makes the life easier for the admins of the system. If you move to the next slide. So this is a typical deployment of Zenko on-prem on 5 machines. So the system is a scale out, so you can deploy 5 and talk to any of the servers, and you get the same namespace, the same content. The database MongoDB is distributed across the cluster, and it's set up so that you can lose 2 nodes at the same time and still have access to your data, and still can write into the system even after 2 server loss. Typically, the metadata goes on flash drives or fast storage because you do a lot of metadata queries. And the data itself can go directly into the cloud or can go to an on-prem object store. If you move on to the next slide. Metadata is the heart of Zenko. We talk about this more later on, but you could deploy Zenko without any storage attached to it directly, just as a kind of a routing engine for your storage. So it's fully decoupled from the storage location, and everything that Zenko sees is searchable. So we configured the system to index all the object metadata. So so you can easily search. So even if your data is stored on Google and half of it is stored on Azure, you can do a one global metadata search across multiple systems. Next slide. So the policy that we support today are around replication and lifecycle, and we'll come up with more later on. So one-to-one replications, that's easy. You have one cloud, you maybe on-prem to, and you send it to another cloud. One-to-many is kind of something that's unique to Zenko, where you can actually decide to push data to multiple clouds. We see this use case in media as a way to kind of be some kind of CDN and distribute data across multiple clouds. And in that case, you can also benefit from our local caching. So the first copy would be in the cache, and then is it being sent to the cloud, which is the most economic from a bandwidth point of view. There's also lifecycle management, which is the typical AWS S3 lifecycle exploration, and policies are coming later on. If you move into the next slide. So if you were to deploy Zenko on premise, that's an example. At the bottom, you have a ring. So it's a Scality distributed object store. So you may have hundreds of petabytes of storage on-prem. We decide to deploy Zenko. Zenko can read your existing data, and actually you don't have to transfer it for Zenko to see it. Then you can decide to transfer some of your data to any cloud, and you can do that all from the UI of Orbit, or in a graphical manner. So if you move to the next slide, in that case, Zenko is running in the cloud, so maybe in a Kubernetes service or on VMs, and it gives you the same feature. The way to decide if it's on-prem or in the cloud depends on your bandwidth usage, and you have to look at the cost of bandwidth depending on the kind of traffic you're going to do. Next slide. It's all one single namespace, but we also designed it so that if you don't like Zenko in the future, you can unplug it and go access your data directly. Right? We're not trying to lock everybody in. It's our philosophy of Zenko. Freedom and control at the same time. So it's open source. It doesn't transform your data. It keeps the metadata intact. So it's a very, very open product. Next slide. So some of the philosophy that I have behind Zenko, one is, we've been working with enterprise companies for a very long time. There's existing data, and we cannot ignore existing data. Right? So Zenko is compatible with data you have already. Today, data that's already stored on Scality Ring is visible to Zenko, and you will see in the roadmap when Stefano talk about it that we also going to add support for NAS. So if you have an existing NAS system, petabytes of file system data, you'll be able to see it in Zenko without having to copy the data, just loading the listing into Zenko and being able to manipulate the data as if it was in any cloud. Also a way to federate multiple storage. A lot of enterprise customers we talk to have a variety of different storage for different applications. You can have all of them seen as one big namespace through Zenko. So in that manner, Zenko can work out of band. So you don't have to connect to Zenko to read or write to data. So we are writing extensions so that Zenko can be notified when data changes in the cloud. So imagine that in a workflow, you send data to the cloud, to AWS, for it to be processed, and the processing generates new data. You want your application in the cloud to directly write to Amazon S3. You don't want it to write to somewhere else, especially for bandwidth reasons. But you want Zenko to see it. So Zenko will be able to connect to the AWS notification mechanism and detect changes to a bucket that happen remotely. And of course, Google and Azure are next. Zenko is very extensible. It's open source. Everything happens online. Our developers go online. They go to the forums. It's all an open project. And now we're going to explore having some more complex workflows. I should say powerful, more than complex, that will allow to save a lot of time. So we've been talking to AI companies that do a lot of AI, and you see the data scientists are kind of wasting time doing their own script, doing their own compression, doing their own kind of manipulation of data. We want to be able to create workflows inside of Orbit itself in a graphical manner. So if data comes from this bucket with that metadata, then can you please encrypt it with that set of keys and slice it and send it to that cloud? So you'll be able to do that graphically through Zenko. And so we're asking for input, and I think Stefano will talk more about that later on. So I wanted to give the idea of why Zenko is unique compared to other offering in the market. And I think that's it for me.
It's a very fascinating realm when to realize that cloud storage, object storage, always been considered the simple use case of the cloud. Like, well, it's a dumb bucket. You drop objects in it, and you don't have to be worried about it. But now things are becoming a lot more complicated as you dive deeper, and as the amount of terabytes keep increasing, having to deal with multiple vendors and multiple storage places it gets quickly complicated. So I mentioned at the beginning, we have released 1.0 version of Zenko with a whole lot of capabilities already. We're pretty happy with it, but we're already thinking about the future. And in no particular order, we've put in the backlog a few things that we want to add. Giorgio mentioned some of them already, like out-of-band updates for existing and new data. This is an important feature because we want Zenko to be at the center of data management and control of data for all of the users out there, and we want to be able to ingest data without Zenko to force Zenko on everybody. We also want to be able to add automatically metadata tags to objects and improve the metadata search capabilities. And definitely we want to expand the list of supported cloud backends. Giorgio mentioned that we now support Amazon S3 APIs and Google Cloud APIs and the Azure Blob Storage APIs. And that's already in and of itself a quite compelling story, because as a developer, you don't have to think about which APIs you're going to be supporting. It's already a major choice once you're developing new applications. And having to just rely on S3 is a little bit of less of a headache. But having to support more like Backblaze or IBMs or other object storage as they come is open, because the microservice called Cloud Server that does the translation between these APIs is fully extendable, and it's open source, and it's accepting contributions too. So if you see the list of APIs missing, then we can definitely accept. We have documentation also for adding new backends. Support for file systems like NFS and SMB also is something that we're working on with a lot of interest from potential users and customers. But the most important one that we're focusing on in the next few months is the workflow manager. Next one. So for the workflow manager, the current setup is that, as Giorgio mentioned, it's revolves around replication and a lifecycle expiration. But we want the new version, the next version, to be a full-fledged system with API for asynchronous and synchronous jobs and tasks, where applications can be sending data to the workflow manager, and APIs can be plugged in to do things like, for example, check that if that file being uploaded is actually covered by copyright, or is there a virus in there? So like simple thing like virus scanning, or is this document fully encrypted and signed with the right keys before it gets stored into Zenko. So all of these tasks right now, they are done with, they can be done but with involvement of data transfers and bandwidth movements between, and therefore costs between the different storage locations. We want this to be done inside Zenko in a smart way, so that the metadata is stored also and control is maintained and kept. We have designed the system. We have an idea what the system will look like. If you go to the next slide, we have documented it in our repository, our public GitHub repository, where we keep the design documents for Zenko. And the link is on the slide here. But like we did Zenko, we originally developed it with talking to customers, asking them what are your problems with storage, what's coming next. We want to do the same thing with the workflow manager. We are going to setting up meetings with potential users, partners, whoever designs applications or has services that can be manipulating data, analyzing data and objects specifically, and that work with the cloud. We want to talk to them and get their feedback early on, and co-design this feature and co-develop eventually. We're open to that too, of course. We have opened discussions on our forums, and we already set a date for the first meeting with our co-design team. We're going to be in Las Vegas during AWS reInvent, November 26 to 30. And we have a form on the website on scality.com where you can sign up and leave us a note and say, we're interested in discussing with you the workflow manager. And with that, I think this is your turn. Of course, you can sign up to Zenko as we chat and the forums as we chat. But and let's get to the questions. We have some there from Brian. All right, so does Zenko have its own meta repository to track key value, metadata on objects?
So the answer is yes.
Right, we've seen it with, it's based on MongoDB, part of the...
And the metadata is a native object metadata, but also replicated to the different cloud targets.
Perfect. So the same metadata that are in the origin object dropped into S3, for example, is replicated.
Is replicated to Google
with the same.
Any cloud.
Next question is, we have a large enterprise object store with over 10 petabytes of data and over 1,000 buckets. It's internal facing, internal applications, developers, archives, etc. Would Zenko sit in front of the object store, become the primary S3 endpoint for all apps and consumers using our object store?
So it doesn't have to be. It could be, but I see no problem with having Zenko front existing storage and give you an S3 compatible API, whatever the API of the existing object storage is. That works. And it's fully scaled out. If you don't want it because for some reason you have used the other API or you have existing data going to that API, it's compatible to go directly through the other object store as well.
Right. You can use Zenko to ingest data from the existing store.
And you can still read it from the existing data.
Yeah. And the other one, does Zenko have its own life cycle for objects? For example, would be our own backend object store does not have expiration. Would Zenko be able to delete objects upon expiration?
Yes, that's correct. And that's a use case we've seen 2 times now, where people can use Zenko to augment the feature of an existing object store that's lacking this feature. So in the example of Ceph, it doesn't have lifecycle management, it doesn't have replication to the cloud. So if you pair Zenko with Ceph, Ceph now has these features.
The question is, can Zenko keep up with a high request rate S3 customers, such as 100 plus new objects per second?
Yeah. So the stack of Zenko, as I said, is based on a cloud server, which is something we use in the enterprise with Scality, and we've scaled to tens of thousands of requests per second. So Zenko is capable of doing the same.
And another question is, their support for IBM Cloud Object Storage backend, on-prem or public?
So being ASP compatible, I'm sure that it could be a target of Zenko. Now being notified of change happening in the backend requires more integration, but as a pure target of Zenko, I don't see why not.
So adding a target like a cloud server backend, yeah, it's a simple task, in fact. Yeah, it's actually something that can be done very quickly also by an open source contributor because it just requires copying and pasting of a few lines of code and changing the configuration.
So it's simple because it's already S3 compatible.
Right.
So it's just a matter of having the right entry in the UI.
Right. And the sample code would be the Wasabi integration that
yes.
Yeah. Or DigitalOcean, for example. Yeah. So we didn't talk much about. I have a question. We didn't talk much about deployments of Zenko, so we just mentioned it. Giorgio, do you want to talk about the Helm charts and the repositories and where it can be deployed?
Yeah. So Zenko can be deployed on any Kubernetes distribution or instance. It's a set of Helm charts. So it's basically one command. Once you have Kubernetes deployed, it's one command to deploy the Zenko Helm chart, but we pull all the dependencies and all the packages that you need.
And once you deployed on premises on your laptop, for example, for a test or on a set of servers or on Google Cloud, what would you do to connect it to Orbit?
Yeah. So there's a unique ID that's automatically generated each time you deploy Zenko. And you will need to get that instance ID and go to Orbit, so which is on www.zenko.io. Go there, and then you will have to associate this instance ID with your Orbit account. So
your Orbit will talk to Zenko on premises and be configured remotely.
So the way that it works, it's a secure HTTPS connection. And it's never from Orbit to your instance. It's from your instance connecting into Orbit. So it's only one way.
One way on the outside. So no holes punching inside the firewall. And so, but once you establish that connection, do you have to keep it, or can you just drop it?
So you can drop it at any time. And Zenko doesn't need Orbit to run. So.
And what happened to the metadata database?
So all good questions. So the metadata stays where Zenko is deployed. So none of the metadata makes it to the Orbit UI. So if you disconnect Orbit, you still have all your metadata alongside Zenko.
Cool. And we haven't mentioned the open source release. I mean the license. Zenko is available under permissive Apache version 2 license. And all of its pieces are on GitHub. If there are no more questions from the attendees, any curiosities? Does it look like? Then we can probably just close it here. And thanks everybody for coming. We hope to see you in Las Vegas. If not, one last question. Can Zenko be used to migrate data between clouds?
So for existing data, you need a way to tell Zenko that this data exists. And we don't have the out-of-band feature yet, but when we have it, you'll be able to do that automatically and migrate from one cloud to another.
Yeah. Of course, we're open also to answer questions on the forums. It's another good way. People are already doing that. Kevin asks, does Zenko have any plans to integrate with decentralized cloud storage layers? Decentralized cloud storage layers.
Maybe talking about storage or some other system? Storage, I mean.
Storage, yeah, storage. Yeah, good question.
So we have some interaction with storage right now. It's kind of new, but for us in the roadmap or in the direction, we want to support as many backends as possible. So decentralized storage is part of it too.
Yep. All right. Our forums are open 24/7. We have offices in Paris and in Europe. We got another question asking for what is the Orbit website. That is the configuration management system for configuration and control system for Zenko. So once you deploy your Zenko instance, you can configure it on your own with whatever your Ansible, using the Helm charts that are provided, and or you can connect your Zenko to Orbit, the administration panel.
And so to connect to Orbit, you have to go to zenko.io, and there's a try Zenko at the top right of the page, and it logs you into Orbit.
Yeah. Smooth. And you can also, from there, you can also very quickly create a sandbox. And so you don't have to install it on your own. You can do all the tests quickly on your own.
Yep.
Connected to your buckets and to your cloud instances, and try replication with all within the UI.
Just to make it easy, when you go to try Zenko, it's going to ask you to log in, and you need a Google compatible account to log in, and you don't have to have created an account before. You can just log in your existing Gmail credential, and will give you an access to Orbit automatically.
Yep. Okay, I think we're open on the forums. You can ask. It's very easy to use the forums. It's very easy to log in with GitHub credentials, Gmail, your own email account, and ask us questions there. We're gonna be happy to respond, to give you our thoughts. Thanks, everybody.
Thank you.